All right, does everyone have a paper? Okay. So we have already learned everything on this front page. It's just a reminder. A lot of times the three most common examples of models are linear, quadratic, and exponential. And so this, like one way to determine the appropriateness is just to look at the scatter plot. If the data points pretty much line up linearly, then we'll say it's linear. If you're looking at the data, then you can tell that there is a relatively constant rate of change for linear. All right, and then quadratic, the data is about U-shaped. You have some today that you're going to do that. It's they're more like V, but it's fine. So the rates of change are increasing or decreasing at a relatively constant rate. And then exponential is the newest one we've talked about. And on the output values, they are roughly proportional, or that each successive output value is the result of repeated multiplication. So none of the activities you did yesterday were exponential. There is M&M exponential activity, but you do it in Algebra 2, so I didn't want to do it again. So that was the one where you eat the ones with the M's that were facing up. You guys remember doing that? That's exponential because they're decreasing by about a half each time, or you're multiplying by a half. All right, so this is the exact same thing that I put on your sheet. So if you don't have it, it's fine. You'll have it in your notes. In that we can find the residual by taking the actual value and subtracting the predicted value. So what we're going to do on this example, and I'm going to trust that you know how to do this because we've done it so much, that I put this data in the calculator, and this data, it's the weight, well, hold on, from the beginning. The weight of newborn babies can be modeled by a linear function for the first 4 months after birth. Selected values of the weight in kilograms of a particular baby are given in the table below, where T represents the number of months since its birth. We're going to use the regression capabilities of the calculator, and you can do this yourself, or you can just do it, or you can just watch me do it, either one, to find the linear model of that form. Now, this form, the one where what you learned in Algebra 1, the y-intercept is first and the slope is second, is what they use in statistics. The other one will give you the same equation, but if they ask for it in that form, let's go ahead and give it to them in that form. And so we're going to go to Stat, and we're going to go over to Calc. And then the one they're talking about is number 8. And I'm going to use it in a second, so I'm just going to go ahead and store it for Y1. That's always a good habit. All right, there we go. And we don't have to round here because we get exact values for our function. And I'm going to call it what they did in the problem. So this is W of T. And it should be 3.34 plus 0.8 T. All right, and then we're going to use this model to make a prediction about how much this baby is going to weigh at 2.5 months. All right, since it's in our calculator, we can just do Y1 and put 2.5 in parentheses. I hope that's something you guys are pretty comfortable doing. And so, according to the model, the prediction of this baby at 2.5 months is 5.34 kilograms. All right, now here's the new thing. So the actual weight of the baby at 2.5 months after birth was 5.5 kilograms. What is the residual? All right, so residual is the difference between the actual and the predicted. And so try to remember the alphabet. I know you guys know the alphabet. The actual is going to come first. So the baby actually weighed 5.5 kilograms at 2.5 months. Our model predicted the baby would weigh 5.34 kilograms, and so the residual is 0.16. All right. And then did our model underestimate or overestimate the weight? What do you guys think? Under. The model predicted something lighter than what the baby actually weighed. Now that's obvious when you look at the values. Sometimes I think they might just give you the residual and you have to make that decision. So a positive residual is going to be an underestimate and a negative is going to be an over. And that might be really hard for you to remember like in May. And so just try to, like I would just go back and like make up some numbers and subtract and see which one was bigger. Okay, then this is what is important. And I heard some people thinking that they were doing the residual wrong because they were just getting points all over the place. That is what you want. And so we are going to use a residual plot to check the appropriateness of the model. What you're looking for is no pattern. And so if your residual, if what you graphed for your car activity was just kind of points all over the place, no pattern at all, then that means that the linear model was appropriate. If you get some kind of pattern, and you'll see what the pattern looks like, where everything lines up in a straight line, or there's like this curve that you can just follow through, then it was an inappropriate model. Then we should use something else for our prediction model. Okay, so here we go. Now these questions get kind of complicated, but pay attention that this is the residual plot. It says these are your residuals, so that pay attention to what you're given each time. So on example 3, and you do have to read every word, and I'm bad about skimming over words, but an exponential regression was used to model a data set. The residual plot for the exponential regression model is shown above. Which of the following is the best conclusion about the appropriateness of the exponential regression model based on the corresponding residual plot? So do you see a pattern, or is this just kind of random dots? No. There's no pattern. So no pattern means appropriate. Okay, so there's 2 that say appropriate for the exponential regression. So make sure you choose the one that gives the reason why it's appropriate is because the residuals show no pattern. Okay, this is a pretty common question question that Brian Passwater likes to make up, where you are given 3 or 4 residuals and you have to answer questions about appropriateness. So a group of AP pre-calculus students used a set of data to create a linear, quadratic, and exponential regression models. After creating the models, the students created a residual plot for each model, and that's what we have. Based on the 3 residual plots above, which model was the most appropriate? What do y'all think? Yes. It's the only one that there's not a clear pattern. Like you can follow these points and they make a shape, like it follows a pattern. This one is just kind of like all over the place. That's what you're looking for. You want it to be all over the place. So exponential model was most appropriate. And the reason, if you're using residuals, the only reason that you can say that whatever is most appropriate is you would say the residuals show no pattern. Or if you want to give a reason why something is not appropriate, you would say the residuals show a pattern, a clear pattern. All right, and then example 5. This is the other way that we determine appropriateness of a model is looking at the context. And you guys did this yesterday with the M&Ms, and we did it on a lesson previous. But Ms. Perry hopes to make it into the Guinness Book of World Records by painting the world's biggest mural on the sides of several downtown buildings. Her mural will consist of many painted circles of various sizes, where each circle is painted a different color. She wants to create a model to determine how much paint is needed in quarts for a circle of radius R in feet. Okay, so should Miss Perry use a linear, quadratic, or exponential model? Quadratic. Why quadratic and not exponential? Right. The pattern that she's doing involves area. So it would be exponential. There is one on your assignment that's exponential. Exponential is something is growing by a certain percentage or decreasing by a certain percentage or a certain rate. That would be exponential. Now this next question I think is kind of tough, and I honestly don't know how to interpret it. And that's kind of statistics for you. It's very not black and white. So after creating her model, Miss Perry uses it to purchase different special paint colors to use on her mural. In this situation, do you think it's more appropriate for the model to underestimate or overestimate the actual amount of paint needed? So when I first read it, I was like, well, which would be most helpful for the model to over or under? What would you answer that question for? Over, so she wouldn't run out of paint. But then I was thinking, I don't know if that's really what it meant. So then I thought, well, maybe it's like in reality, when she did this painting, would the model over or underestimate how much paint she actually used? I think that might be what the question's asking. And I think that might be under, because then you have to go back and touch up like mistakes that you made. You might actually use more paint than not. So I honestly don't know. You can answer this whichever way you want to. I saw what the answer key said, but it doesn't feel right to me. So either way, this is more like a kind of opinion question. If you think about what would be helpful, or if you think about what might actually happen in the painting of this mural. All right, so what questions do you guys have? Residuals is a brand new concept for you guys. So the main thing, remember, when you're finding it, it's actual minus predicted. The predicted comes from a regression model. And then if you're trying to decide appropriateness, no pattern is appropriate.